Yeah. So today we'll discuss about this assignment 10. Okay. Today is a live session 10. Just a second. I'll just do some settings, then we can go further. My voice is clear to you? Yeah. Okay. So this is the question number 1 for assignment 1, assignment 10. Do you have any specific doubt? You can tell me now itself. Have you felt any doubt in solving assignment? Because the last date, the due date was 4th of October. Did you submitted this, Anirudh? Yeah. Okay, nice. So the first question is what are the possible manipulations that could be performed on the input optical radiation in order to obtain the modulated output as shown in the figure below. So first it is in the constant power is coming the input power with respect to time, and we are modulating to the wave. Okay, so here what do you think, what could be the answer? All of the above. Yeah, that's correct only. I think you have done this assignment. The modulation can be carried out through manipulation of the polarization of light or through external radio frequency wave and acoustic wave. Okay. Just a second. Okay, so the next question, it was quite simple. We will move toward the next question. Here the question is light at a wavelength of 1550 nanometer propagates through a biforensic medium with a refractive index Ne of 2.0 and refractive index No of 1.5 over a distance of 1 micron. The phase retardation experienced by the light is, in radian you have to tell, with 2 decimal accuracy. So here the solution, it could be like 5. You have to calculate the phase retardation. So did you solve this one also? Anuj, did you solve this? Okay, what could be the answer here? Can you just let me know? 2.02. Yeah, very nice. So what you have to do, 5 is equal to 2 pi by lambda into Ne minus No into D. Okay, distance you have to, like all these values you have to put, wavelength, refraction index Ne and refraction index No. Then we get the 5 value. sorry, this is 2.03 radian. Okay, now next question. Question 3 is consider that an electromagnetic wave can be represented by the following components. These two components are there. Ex is equal to E cos omega t minus kz, and Ey is equal to minus E cos omega t minus kz plus 90 degrees. Okay. So then find the direction of propagation and the state of polarization. So here, can you tell me once if it is okay for you? Anirudh? So question number 3. Which one is the answer? A, B, C, D? The first one. Okay. So here what is happening, the phi is saying that it's a right circular polarized light. Okay. And the equation has given like cos omega t plus kz. Okay, it shows that the electromagnetic waves are propagating along the z direction. Okay. So this z direction and right circularly polarized light. So option number A is correct. Okay. Now question number 4. Which of the following is used as a polarization rotor with a reciprocal nature? Can you tell me this one? The previous question. How to rewrite the EY equation? Okay, wait. EY equation. If you will just this negative minus cos theta is there. So if you will convert into, if you want to convert into, suppose this is there. Okay. Cos theta plus 90. You have to check for inside the like how we can convert the theta. Okay, so it is coming in the first here all will be positive. Okay, just a second, I'll just confirm once. That will be better. any particular process. I think Anirudh, I have to check that something like cos minus theta is equal to, you have to convert into the cos minus cos theta something. Okay, so yeah, I'll do one thing. While I'm pasting, while I'm providing this link, YouTube link, with that, along with that, I'll just give this solution. Okay, how it is happening. Yeah. Okay. Meanwhile, you can also find out why it is happening, what is the formula for that. Some formula is there. Okay. Yeah. So which of the following is used as a polarization rotor with a reciprocal nature? So here we were. So what do you think here in question number 4? Half wave. So what is happening in half wave? Half wave plate. So as a given of x and y component, suppose the x component remain the same, but y component get flipped. Okay. Yes. Yeah. No. This is no. X won't be flipped. Only y will be flipped. Yeah. Okay. And through that it will generate the output phi phase. Okay, that will be difference. That will be the difference between this output and input. So the half wave plate can be used as a polarization rotor. Okay. Better I should keep some image here. Something like okay. I think you can understand here. Is it visible for you? Yeah. So what is happening here? There is like a so xy component is there. Okay. In that x component will be remain same. Suppose this x1 and y is like this. Okay. Here, yeah. So one is changing here. This can be flipped either like this, okay. This one will be constant, and based on that we can say that the output phase will be different by 5, okay. It will be like 180 degree phase change. So that's why we can say that it is like a half wave plate that can be act as a polarization, okay. Now question number 5. In the question below, the following statements are marked as assertion A and reason R. Mark your answer as per the code provided below. So assertion is given that a Faraday isolator for one wavelength will not provide the same isolation for same other wavelength. Reason 1 is given like Faraday isolator is a non-reciprocal device. Reason 2 is given the word constant depends on wavelength. So assertion, reason 1, first option is assertion, reason 1 and reason 2 are correct, but reason 1 is the correct explanation of assertion. Option B is given like all assertion is correct but the reason is not correct. Assertion, reason 1, reason 2 are correct but reason 2 is the correct explanation of assertion. And the fourth one is assertion, reason 1 and reason 2 are correct. Both reason 1 and reason 2 are the correct explanation of assertion. So here please tell me what could be the answer here. The question number 5, did you do this? Yes. Yeah, you are correct. Third option is the correct option for this. So it's basically a Faraday isolator for one wavelength will not provide the same isolation some other wavelength for some other wavelength, okay. So and it should have been determined by Moll's law, like things like okay, I'll just read this one. Solution is written as the Faraday isolator for one wavelength will not provide the same isolation for some other wavelength, okay. As with some other wavelengths, theta will be different and it needs to be determined by Moll's law, okay. Moll's law should be determined by Moll's law. So that theta will be different for different some other wavelengths, okay. So that's why this all are correct but the reason 2 is the correct explanation of the assertion. Okay, question number 6. A beam of polarized light passes through. Oh, sorry. Okay, question number 6 only. Yeah, a beam of polarized light passes through a Faraday rotor placed in a magnetic field of 0.1 Tesla and a length of 0.15 meters. If the word constant for the material is 2.5 radian per Tesla meter, the polarization rotation of the light after passing through the Faraday rotor is in radian with 2 decimal accuracy. Okay. So here what could be the answer? Anirudh? Can you tell me what will be the answer here? .02757. Okay, you are, yeah, it's almost, yes, theta is equal to VBL, yeah, it's correct. Word is constant 2.5 into 0.1 into 0.15. Okay, all will come in the radian. Unit will be radian. Now the question number 7. What is in this? 0.0375. Is correct? Yeah. Now the question number 7. In the question given below, there are two statements marked as assertion A and reason R. Mark your answer as per the codes provided below. Okay. Assertion: the statement of polarization of light can be changed from linear polarization to circular polarization or rotated. The reason is given the response of the medium to an electromagnetic wave has to be isotropic in nature. So first one is both assertion and reason are correct. Reason is the correct explanation of assertion. Second option is assertion is correct but the reason is not correct. Third one is both assertion and reason are wrong. Fourth one is assertion is wrong and the reason is correct. So what do you think about this one? Anirudh? Reason is wrong but you need bifurcating medium. Yes. So here the state of polarization of light can be changed from linear polarization to circular polarization or rotated. So for that we need bifurcating medium. So that will be having different refraction index with different plane. Suppose in this plane it should not be, the refraction index should not be as the other plane. Okay. That's why this light goes in a different phase. It changes to different phase, and the option 2 is the correct option for this. It should be anisotropic. Okay. Yeah, birefringent medium is not isotropic, so yes, it is anisotropic medium we can say. Okay, now we'll go for the next question. That is, which of the following properties is shown by the photoelasticity? Circular, Faraday rotation, isolation, bifringent. What could be the photoelasticity? Like what is the property? It will show photoelasticity. The fourth one, bifringent. Why you are telling like bifringent? Any reason, particular reason? In photoelasticity, what is happening actually? Please tell me. Yeah, so you are writing, I guess under stress they change the optical property in one particular direction. I feel like we have seen some glasses or something, some plastic suppose. It will like if you press, then the color will change. So many colors will see, like a rainbow color, some types. Okay. So while it is deforming, that time what is happening? It will scatter light in a it will be having different refractive index because of this deformation. Okay. So maybe it will be W refracting or something else, multiple reflecting also. So it will be like bifurcation. Okay. This one. The refracting index will change by particular direction, like from each other. Like suppose in xy direction something else is there. The refracting index of x is different while stress is applied than y. And previously it was like the refracting index was same for both. Okay. Now we'll go to question number 9. Here, which of the following components can be modified to function as a circulator? First option is polarization insensitive isolator, polarization insensitive isolator. The option number is second is polarization sensitive isolator. Third one is half wave plate. Fourth one is quarter wave plate. Option A is yes. So polarization insensitive isolator will be the answer here. Okay, now we'll go for the last question. Here, consider the figure below drawn and match the following regions marked. So this is the figure is given, and we have to mark like option A is given that A is equal to refractive index, B is electronic resonance, C is loss, D is molecular resonance. B is loss, A is refractive index, C is molecular resonance, D is electronic resonance. Option C is A electronic resonance, B molecular resonance, C refractive index, and D loss. And the last option is A is molecular resonance, B is loss, C is electronic resonance, and D is refractive index. What do you think about this one? Option C. Okay. Okay, so here this its solution is like the plot shows the real and imaginary part as a function of frequency. The real part and the imaginary part are related to the Kramers-Kronig relation. The real part corresponds to the refractive index, which is what C. Okay, that is the real part. And the imaginary part corresponds to the attenuation term. Okay, it's D. And the two peaks shows resonance, which are molecular and electronic resonance. Okay, so first one, A is molecular resonance, sorry, A is electronic resonance, and B is first B is there, so B is molecular resonance. Okay, option let's hold option A. Option C you are telling me. A is electronic resonance, B is molecular resonance, and C is refractive index, and D is plot. Yeah, you are correct. Option C is the correct answer for this. Okay. So till here, yeah, this was the last question. Now, if you have any doubts, you can text me. Okay, so telling cos x minus pi is equal to minus cos x. Next question is third question. Here the option C is correct. Yeah. Okay, we got it. This one is like you are telling cos x minus 5. Okay, but here in 90 degrees here, we have to check this. Okay. Is equal to minus cos x. We can convert this one, this value to this value. Okay, so here you just keep inside this one, maybe it will convert. Okay, so how it will be? E cos omega t minus kz minus 180 degree we can say, plus 90 degree also we can say. Omega t minus kz minus 90. So pi by 2 phase difference is there. Yeah, it's correct only. Okay, so like that you do. Okay then, any other doubt you can ask me. If I am not able to answer, then professor, I'll forward to professor, he will answer. Okay, please tell me. Oh, okay. Okay then. Thank you so much.